Hi, my name is Steve Holland, and I'm with Rapid Tech. And for those of you watching this through the Rapid Tech training series or the training program online portal, for you students, make sure you have your online, your supporting document downloaded and printed out so that you can follow along. And as you know, with all Rapid Tech courses, there'll be a quiz after this one, and then you could advance to the next class. This is the Heat Exchangers Failures and Identifications course. There are quite a few videos in this series, but this is on the Carrier and Bryant. Be the Carrier 58 MVP and then the Bryant 355 MAV. Essentially it's the identical furnace, different sticker on the door. What we're going to do is we're going to go through this and we're going to look at where they fail, what to look for, and why it's an issue. So with regard to that, I just want to show something right here. This is the washboard section of that furnace, and I have this circled. You can't see it, but there's a fracture in this washboard right there. So when we get into this, I'm not going to talk too much about that because I don't have a video. I don't have any video coverage of that in this particular one. But I did want to share that for those of you in the Rapid Tech program, that most of this video is talking about checking the secondary heat exchanger. I want you guys also to be watching that primary washboard. But let's go ahead and get started. This video here, what I'm going to do, and by the way, there's another video just like this on YouTube. This is the improved audio version. So hopefully if you're seeing this, you're thinking, gosh, this is redundant. It is a condensed video, and it is better, obviously much better audio. And because we're using several microphones, and we're using a sophisticated camera, I think I finally figured out how to properly do these without that audio being so annoying. But let's go ahead and let's take a look here. I'm going to turn the audio down because I'm going to do voiceover. Oops, let's go back. Alright, so all I'm showing here in the video is that this is a 58 MVP 060. And with this particular model, the 060 just represents the BTUs. Carrier manufactured this furnace in a 40,000, 60,000, 80,000, 100, and 120,000. On some of their other furnaces, now the MVP was their variable, meaning it had the ECM variable speed blower motor, and then it also had that multi-stage gas valve, which was actually a two-stage system. Here I cut the back of the furnace open when I wanted to find out to see if I could find where the failure was. And I know there was a failure on this furnace, but I didn't find it right away. I wanted to start in the beginning because this is what technicians do. What I'm doing here is I'm looking down from the top, and I'm looking down at that furnace, and I'm looking at that secondary heat exchanger. And then what I discovered, and I'm setting up right here, I'm just kind of getting into position. There's the vent motor. Now that, by the way, for you techs, if you ever see a rectangular vent motor like that, that's an ECM vent motor. The round ones are the non-ECM. They're actually PSC. They have a little 3 microfarad capacitor. Most of them did. But that's an ECM vent motor. So that the minute you take the door off this furnace, you know immediately that this is a 2-stage variable speed gas furnace. So that's not the purpose of that portion of the video, but what I am trying to do is show you, I pulled the blower, and I'm going to show you the secondary. And I may even fast forward here because I had a little difficulty. Realize I have a monitor and a camera and one arm doing this and one arm adjusting, so it's not easy, but I want to show you something here real quick. You should be able to see already the corrosion that I discovered. Now the only way that you're going to see this is if you remove the blower motor. Notice I looked down from the top with my camera, and I was looking down from the top. I couldn't find it. You can look from the top all you want, you will not see it. So this is the corrosion, and out in here in the video there's a better shot of that. So let's just go ahead, and I may even fast forward to accelerate. Oh, there you can see it real well, the corrosion. And that's a problem. You don't want that. If your furnace has that, that's a problem. That secondary has failed, and it's because of the polypropylene that's breaking down. And now the condensate that develops inside of a condensing gas secondary, this is a condensing gas furnace. You have condensation that forms in here, and then it travels, that condensation travels to the front of that furnace into a collector box, and then there's a small black drain hose. It looks like corrugated drain hose that'll go over to a drain trap, and that's how that condensate leaves the furnace. However, that condensate is acidic, and that condensate will destroy metal. That's why most secondaries built today, they're made out of stainless steel. This one was an aluminized steel with a polypropylene coating. So let's just go, and I'm going to advance here. Oh, right there. That's right where I wanted to be. So as you can, if you look here, you'll see, let me see if I can get a better shot. You can see the corrosion much, much better in this shot. So that's really what I wanted to show you on this particular model. Now, I'll give you some bonus information. This is the 355 on the Bryant side, and it's the MVP on the Carrier side. It does not matter. This particular secondary was also available in the 340 series by Bryant, the 350 series by Bryant, and then the 58 SX series as well. So it's just look for the 40-inch furnace. Carrier, Bryant, and Payne. You see that 40-inch furnace, and you're going to be able to identify. Now, why is this happening, or why did it happen? Well, it happened because of what I consider poor design. Here's what I will share with you. This secondary was fantastic, a fantastic concept. The polypropylene breaking down was not so good. So the breakdown of that polypropylene is what really caused this problem. Now, with that said, Carrier did stand behind it, and they had a service bulletin out, and contractors that represented these brands, we were one of them. We serviced many of these customers and took care of them. So it can be taken care of. So homeowners, and I know homeowners watch these videos on YouTube, so have your system serviced. And make sure that your technician that's doing the service is checking this. And I'll share with you on the next slide what they need to do and how. And by the way, for those of you technicians in Rapid Tech, you need to listen so that you're following these steps, because one, pulling the blower is super important. Two, checking that washboard on that primary is important. And then the third thing is that combustion analysis. So let's go ahead and look at the next slide. Here we have some different furnaces that I dismantled. I took every one of these apart and investigated them. Here's that Bryant 355 MAV 060-100. Now, don't get confused by Carrier and Bryant. Carrier, if you look here, it's the 58MX060. That's the BTUs, 60,000. Look at 1, 2, 3 cells, 60,000. So if you look at the Bryant 355 MAV060, 9 out of 10 technicians are going to say, if they don't know the nomenclature, they're going to say, oh, it's a 60,000. No, it's not. In the Bryant, the 60 right here represents its blower capacity. And for those of you Rapid Tech students, you know that 12,000 BTUs, okay, 60 represents what? 5 tons, right? So that's a 5-ton blower drive. That's all it means. This is your BTUs right here, 100. All right, so a little bonus. This is what's happening. They plug up. So here's what I want to share with you. If you just inspect the heat exchanger with your visual tools or your sophisticated camera system, that's not enough. You must connect your combustion analyzer to the exhaust and check that carbon monoxide. Notice down here, secondary plugging is what I wrote about. So plugging here, plugging here, plugging here, severe plugging here. When you see this, now realize I took these furnaces apart, dismantled them. You're not going to see this by taking the door off the furnace. You have to literally break these things down to get to this point. So you won't see this. Here's what you will identify though. You will identify elevated carbon monoxide in your exhaust. Any elevated carbon monoxide in the exhaust is reason to condemn that secondary and get that thing replaced. It's also reason to go one step further and check and see if it's plugged, and also to pull that blower and see if you have corrosion from underneath. So that's very important. Another item that you must understand, and this is so important, is that when you replace a secondary on one of these furnaces, there is an update kit. The coupler box on the back must be replaced. You must do the proper setup. That means checking your gas pressure, checking your delta T's, checking your filter size. You want to go through, clean out that drain trap. You want to go through that furnace and make sure that all of those things are being done. And then check that combustion analysis to make sure you have the correct settings. So important. One other thing, anytime you change a heat exchanger, a secondary or primary of any type, you do those steps, gas pressure, delta T, all of that. You also check your vent termination. You want to make sure that your vent termination outside is not recirculating. So that's just some information that I want to share with you guys. You know, we're trying to make better technicians with Rapid Tech, so watch for that plugging. And the other thing I want to share is anytime that you change a secondary, check that primary washboard. Inspect that primary thoroughly. And because you'll find out that you're going to show up at the job site with the secondary and your coupler box and all this stuff, and you're not going to have the primary cells along. I recommend you take the primary cells with you, because if those primary cells have a fracture in that washboard, you're going to need to change those as well. So hopefully you guys understand this, what to look for in those 40-inch models. Now again, I'll repeat this. The 340 in Bryant, the 350 in Bryant. The MX series in Carrier, and then the Carrier MVP series. Realize all you have to look for, and the Payne, I think it's the 490. I could be wrong, so nobody freak out. But here's the deal, really simple, 40 inches tall. So if it's 40 inches tall and it looks similar to this, you know that you're on the right track, and you know that that's the series of that furnace. They don't make this secondary anymore in their new furnaces. Their new furnaces uses a completely different secondary heat exchanger. So once these have all been retired, you know, you won't have to worry about it. By the way, if you look here, you can see the corrosion on this Bryant one. See that? That came out of this furnace. That's that secondary. So hopefully you guys learned something. By the way, in our heat exchanger guide, all of these pictures are in there. And also out on Rapid Tech, when you go there and you watch this, there's a number of these different furnaces and heat exchangers that you'll have access to. So again, my name is Steve Holland. This is our Rapid Tech site, and essentially if you go to heatexchangersafety.com, you can get access to our Rapid Tech site. Now, if you'd like to join Rapid Tech, you can do that. You just have to register here. Now, there is a cost to it, and it depends on what courses you take, because Rapid Tech actually didn't start as a heat exchanger training company. Rapid Tech is a development organization where we develop technicians rapidly to get them into the trade because of the labor shortages. So that's how Rapid Tech started. Or you can email me at ethoskill@gmail.com. Right there, you can just, it's etho, E-T-H-O, skill@gmail.com. And by the way, etho, for those of you that know, that's ethics. Skill is the training. So we want to create ethical skills and ethical technicians. That's why our whole goal is to change the HVAC industry one technician at a time. I'm Steve Holland, and I hope that you guys enjoyed this. Let me know, by the way. Don't forget to post those comments on YouTube. If you don't like the audio, just tell me. I'll do everything I can to fix it. If you have suggestions, I'll take those as well. But we are working on that. All right? Thank you, and have a great evening.